Hello guys, and welcome back to another video. For this video, I will be going over the 4-point problems for the Math Kangaroo 2012 test in the USA for levels 3 and 4. So let's get started with number 9. You have L-shaped tiles, each consisting of 4 squares as shown. How many of the following shapes can you make by gluing together 2 of these tiles? So we know that the first one can be made by doing this and this. The second one can be made by doing this and this. The third one can be made by doing this and this. And the fourth one can also be made by doing this and this. That means all 4 of the following shapes can be made, which means our answer is E4. Number 10. 3 balloons cost 12 cents more than 1 balloon. How many cents does 1 balloon cost? So 3B. B is a variable that stands for balloons. And I taught you about variables in my session 8 video, which was all about variables, which is already on my channel, and you should watch it because I think it will come in pretty handy. So 3 balloons equals 1 balloon, because it says 1 balloon, plus 12. So that means, since this is addition, to get it to this side, we have to use subtraction, which is the inverse operation of addition. So 3b minus b equals 12. So 3b minus b, we know that this is, let's put it as red. We know that when there's no number, that means, and it's just a variable, that means it's a 1. So this is like 3b minus 1b equals 12. So we know that then 2b equals 12. So now we have to make this 1b. So we're going to have to divide 2 from both sides, because at the moment when a number is next to a variable, that means multiplication, and the inverse of multiplication is division. So b equals 12 divided by 2. B equals 6. So that means 1 balloon cost 6 cents, which is B. Number 11. Grandmother made 20 gingerbread cakes for her grandchildren. She decorated them with raisins and nuts. First, she decorated 15 cakes with raisins, and then 15 cakes with nuts. At least how many cakes were decorated with both raisins and nuts? So to solve this, we know that she made 20, and we want to pretend that first she made 15 with just raisins. So that means she's made 15 with just raisins, meaning she still has 5 more cakes. But then it also says there's 15 cakes with nuts. So since it says least, we want to subtract 15 minus 5, meaning that there's still 10 cakes that have to be made with nuts. And you can't just put more nuts on the ones that already have nuts. So we're going to have to put these 10 on the ones with raisins, meaning that it has both raisins and nuts, meaning that 10 would be our answer for how many cakes are decorated with both raisins and nuts, which is E10. Now, on to number 12. In the sudoku puzzle, the numbers 1, 2, 3, 4 can occur only once in each column and in each row. In the mathematical sudoku below, Patrick first writes in the results of the calculations. Then he completes the sudoku. Which number will Patrick put in the gray cell? So first, let's solve all these equations that we already have. So 1 times 1 is 1. 1 times 3 is 3. 2 times 2 is 4. 6 minus 3 is 3. 6 minus 5 is 1. 4 minus 1 is 3. 1 plus 3 is 4. 8 minus 7 is 1. 9 minus 7 is 2. And 2 minus 1 equals 1. So now we have to fill in these ones that we don't know. So first, let's start with this because it already has 3, meaning that it has to be the one number that's not there, which is 2. Same thing for this one that we now have. The one number that is not there is 2. Same thing for this one. The one number that is not there is 4. Then here, the number that is not there is 3, meaning the one in the gray cell is 3, which is C. 13. Among Nicole's classmates, there are twice as many girls as boys. Which of the following numbers can be equal to the number of all children in this class? So there are twice as many girls as boys, which means that girls equal to B. That means that all of Nicole's class equals 2B, because I'm substituting the girls for 2B, plus 1B, which equals the boys. But we don't actually need this one. I'm just putting it there so it makes it helpful. Plus 1. Now, why am I adding this 1 over here? Well, that is because of Nicole. It says among Nicole's classmates. And so that does not include Nicole. So to make the whole class of children, we have to add 1. So that means this equals 3 of the boy values plus 1. So since this number here is 3, we know that the thing has to be 1 more than a multiple of 3 because this has to be divisible by 3 and then you're adding 1 to it. So 30 is already a multiple of 3, meaning if you add 1, you will not get a multiple of 3. 20. So we have to, so if there are 20 people in the class, we have to subtract 1 from it because that you're subtracting the amount of Nicole. So when you subtract 20 minus 1, you get 19, and 19 is not divisible by 3 because you can add the digits as I taught you for divisibility rules in session 1. That was also a helpful video, so using those techniques, I can apply them when I am solving these test papers. So 1 plus 9 equals 10, and 10 is not divisible by 3. Even so, you're still going to have to know your basic divisibility stuff with 3, because if the number was 999, that's like if you add them 9 plus 9 you get 27, and then 27 is already bigger than 19. So yeah, you're gonna have to know that 27 is divisible by 3. 24, we already know that this is divisible by 3 because when you add you get 6, and 3 times 2 is 6. So when you subtract 1 from it, it is going to be 23, which is not divisible by 3. So now 25. 25 minus 1 equals 24. And as we mentioned here, 24 is divisible by 3, meaning D is our answer. But let's check E, 29. So we subtract 1 and we get 28. 2 plus 8 is 10, and that is not divisible by 3, like how 1 plus 9 is 10. Now, on to 14. In the animal school, 3 kittens, 4 ducklings, 2 baby geese, and several lambs are taking lessons. The teacher owl found out that all her pupils have 4 legs altogether. How many lambs are there among them? Let's calculate how many legs the animals at the school have at the moment, minus the lambs. So a kitten has 4 legs, so 3 times 4 equals 12 for the kittens, 12 legs. Now a duckling has 2 legs, so 4 times 2, you get the ducklings have 8 legs altogether. And then the baby geese also have 2 legs, so 2 times 2, you get baby geese have 4 legs. So let's add this all. 12 plus 8 plus 4, you get 24. So now we have to subtract 44 from this. So 44 minus 24, we get 20. So now lambs have 4 legs. So when you divide 20 divided by 4, you get that there are 5 lambs among them, which is B5. 15. A rectangular prism is made out of 4 pieces as shown. Each piece consists of 4 cubes and is a single color. What is the shape of the white piece? So for the lightest gray, we know all the pieces we can see. Now, we can also see all the pieces for the medium gray right over here. But we know that we don't have one piece from here because there's only 3 and there has to be 4 for each. So we know that the piece will have to be underneath this one. So down underneath this because it has to connect to these. So it can either be here or here. But we know it cannot be here as there is a white here, meaning that it connects under this one. So we know that the white cannot be under here. So at the moment for the whites, we know that this is how it looks. So we know it cannot be here or here because there's already a medium gray here. So that means it has to be under here and then here, because if we were to go forward again, because the only 2 directions it can go is here, we would get right over here, which is already taken. But we cannot see what this one is, which is the one under here. So that means it can be white. So our shape would look like this, which is looking most like D. Last 4-point problem. 16. At a Christmas party, there was exactly 1 candlestick on each of the 15 tables. There were 6 5-branched candlesticks. The rest of them were 3-branched candlesticks. How many candles had to be bought for all the candlesticks? So we know that there was 1 candlestick on each of the 15 tables. So there were 6 5-branched candlesticks, and the rest of them were 3-branched candlesticks. And since there was 1 candlestick on each of the 15 tables, and 6, we already know that there's 6 5-branched ones, that means 15 minus 6 will get us how many 3-branched candlesticks there are, and that would be 9. So now we have to do this equation to solve and get our answer. So 6 times 5 plus 9 times 3, because this is how many 3-branched ones there are and how much candles we would need, which is 3. Same thing for the 6 5-branched candlesticks. There are 6 of them and it can hold 5 candles. So this would equal 30 plus 27, and when you add this you get 57, which gives us our answer of C. And that is all the 4-point problems. So thank you for watching this video. Please like, subscribe, hit the notification button, and keep on watching videos that I will upload on my channel. Thank you. Bye.